The Geometry B Prerequisite Assessment for the spring of 2018 began with something that was designed to find out how much vocabulary the students know. Do they know what the words mean and what the basic relationships are? In this particular case, we have one line crossing two lines. That makes this a transversal crossing these two lines. And the students were asked to identify one and only one pair of angles that fits these definitions. And the definitions were the same on each test, although they were in a different order on different versions. Vertical angles are the ones that are across from each other. And they are at the same intersection. So here that's vertical angles. So any one of these pairs, 1 and 3, 4 and 2, 6 and 8, 7 and 5, those would be vertical angles. Linear pairs are angles that are adjacent and have non-common sides that form straight lines. These angles right here are linear pairs. So 4 and 3, 3 and 2, 2 and 1, 1 and 4, 6 and 5, 5 and 8, 8 and 7, and 7 and 6. Those are all linear pairs. Those are the two examples of angle relationships that occur at a single intersection. These others, alternate interior, same side interior, and corresponding angles, those are what happens when you have a transversal that crosses two lines. Alternate interior angles are the ones that are between two lines and on opposite sides of the transversal. So this is 1 and 5, or 2 and 6. Same side interior angles are inside the two lines and on the same side of the transversal. So 1 and 6, or 2 and 5. And corresponding angles are angles that are in the same relative position at the two different intersections. So 4 is, let's say, the upper left part of the intersection. 6 is the upper left part of the intersection. Those two correspond. 3 and 5 correspond, 2 and 8 correspond, and 1 and 7 correspond. So one example of each of these would have been the appropriate things to put in those boxes. There were several different versions of this, but they all asked the same questions. And the angle relationships here either talk about angles that are congruent, measurements that are unrelated, angles that add up to 90, 180, or 360 degrees. So that for each one of these, that's what we were asking students to determine. The angles of a triangle, those add up to 180 degrees. So on this particular form, the answer to that was D. Corresponding angles formed by a transversal crossing parallel lines. Parallel lines is the key here, because if the lines are parallel, the corresponding angles are congruent, and so in this case that would have been A. A linear pair, linear pairs are always supplementary. Alternate interior angles formed when a transversal crosses any two lines. Well, if they're not parallel, if you don't know they're parallel, then the angle measurements are unrelated. Adjacent angles formed when two lines cross. Well, let's see. Here are two lines crossing. Adjacent angles are the ones that share a vertex and a side, but don't overlap. So that would be this one here and this one here. Those are a linear pair, and so they would be 180 degrees as well. Same side interior angles formed by a transversal, again, crossing parallel lines. Those are also supplementary, so they add up to 180 degrees. And vertical angles are always congruent. This particular problem here has to do with angle relationships and parallel lines. You're given two pieces of information here, and you're asked to find the measure of angle 16. Angle 1 and angle 5 are congruent. The other one is that the measure of angle 12, which is over here, is 125 degrees. And then you're asked to find this angle here. The idea behind this question is to find out whether or not you know the rules about parallel lines and can tell them apart. There are two different sets of rules. One of them tells you that if you know that the lines are parallel, then you know something about the angles. The other says if you know something about the angles, then you know that the lines are parallel. These are called converses of each other. And it's important to know them, and it's important to know the difference between them. In this particular case, it's also critical that you understand that if you don't know the lines are parallel, then you don't know anything about the angle measurements. So you cannot, for example, start here and say, this is angle 12, it's 125 degrees. This is angle 16. It's a corresponding angle. It must also be 125 degrees. That's only true if the lines are parallel. The question is, are the lines parallel? And it doesn't say that they are, but you can show that they are because these two angles are corresponding angles and they are congruent. So line A is parallel to line B because if corresponding angles created by a transversal are congruent, then the lines crossed by the transversal are parallel. This is an example of if I know something about the angles, I know the lines are parallel. Now that I know that the lines are parallel, I know something about the angles. Now, it's important to notice, too, that the only transversal that we're talking about here is this one. It crosses line A and B, and it creates two congruent corresponding angles. It doesn't tell you anything about whether lines C and D are parallel. It just tells you that these two lines are parallel here. But because these lines are parallel, it means that all of the corresponding angles are congruent, all of the alternate interior angles are congruent, and all of the same side interior angles are supplementary, and that's true of every transversal that crosses those two lines. So that means we know that angle 12 is congruent to angle 16 because if a transversal crosses parallel lines, then it creates congruent corresponding angles. And that's how we know these two angles are congruent, because they are corresponding angles in the same relative position in the two different intersections. And now we know that the measure of angle 12 is equal to 125 degrees because that's what it means to be congruent. It means you have the same measure. So definition of angle congruency. And that's what you needed to be able to do in order to pass this standard. The words didn't have to be exactly the same, but it had to be clear that you understood both of these rules and knew the difference between them and when to use them. The triangle congruency standard was represented by two proofs that just needed to be filled in. In this particular case, Kelly started the proof below to show that if, okay, so this is what's given. the if part. TC is congruent to TM, and AT bisects CTM. We got a drawing over here. TC is congruent to TM, and AT, which is this, bisects CTM, which is this, which means that this angle is congruent to that angle. Okay, that's what bisect means. So these things here are what's given, and that's what you write in this box. Definition of bisect. Well, in this case, AT bisects angle CTM. The definition means to cut it in half, and the result of that is that you have two angles, CTA and MTA, that are congruent to each other. AT is congruent to AT, and of course that is true because of the reflexive property. So now, here it doesn't tell you much, but it does tell you that down here you're going to have to show that congruent triangles give you congruent parts. Now, in order for that to be part of this proof, we're going to have to show that two triangles are congruent here. Now, what are we looking for? We're looking to find out that CA is congruent to MA. That would be this here and this here. And they are because these two triangles are congruent. And we know that because we've set it up so that we have one pair of congruent sides here and here. We have another pair of congruent sides here with itself. And the angle between them, here and here. This is what we're going to prove. So this is actually what's going to go down in here. This is what we're trying to end with. It's the then part of the if-then statement. And in order to get here, we're going to have to show that these two triangles are congruent. Triangle CTA is congruent to triangle MTA. And of course it is because we have side, angle, side congruency. The other proof, a little bit longer, is that started to set up a proof to show that if, and this is the given part, right, two pairs of lines are parallel, and two distances are equal. Okay, so let's see what we got here. BC and EF, that would be this and this. They are parallel. AB and DE, that would be this and this. Those are parallel. And AF is equal to DC. That means the distance from here to here is equal to the distance from here to here. Those are the things that are given. Now, the first thing in the proof is that BCF, that's this one here, is congruent to EFC. EFC, that would be this one here. And then also EDF, that would be this one here, is congruent to CAB, and that's this one here. And that's true because the lines are parallel and these are alternate interior angles. This angle right here and this angle right here are created when line DF crosses the two parallel lines AB and ED. And these two angles, this one here and this one here, are created when this line right here crosses these two parallel lines right here. So in both of those cases, we know that these angles are congruent because if a transversal crosses parallel lines, then it creates congruent alternate interior angles. Now here we're talking about the reflexive property, and we've got this blank space. And the reflexive property could apply to anything because everything is equal to itself. So let's look at what the next thing here is. AF plus FC is equal to CD plus FC. So here we're saying that the additive property of equality is what's going to let us do this. And that says adding the same amount to both sides of an equation keeps the equation true. AF and DC are the same amount, but of course we know that because it's given, not because of the reflexive property. What we know from the reflexive property is that FC is equal to FC. That's the reflexive property. Or, if you prefer, we know that the two segments, FC and FC, are congruent. Now, if we add the same thing to both sides, and we know these are the same thing because it was given, we haven't changed anything. And then segment addition, well, AC, that's this segment right here, from here to here, and that's made up of AF plus FC, right here, and DF, that's this one here, from here to here, that's made up of CD, this one here, and FC, that's this one here. Put those two together and you get this segment right here. Now, ABC is congruent to DEF. Let's see, where is ABC? ABC is here, and DEF is here. Now, how do we know that those two are congruent triangles? Well, we've got a lot of things going on here. We know that this is congruent to this, because that's what we just proved here. We know that this angle is congruent to this angle, and we know that this angle is congruent to this angle. So it looks like this angle here and this angle here and the line segment that connects them are all congruent to this angle here, and the line segment that connects them. And that is angle side angle congruence. Now we're going to use the fact that the two triangles are congruent to prove that some of the parts are congruent. Well, there's no way of knowing which ones we're interested in right just off the top of our heads, except that it says in the then part of the statement what it is we're trying to prove. We are trying to prove that BC, let's do that again, BC is congruent to EF. Right. That would be this part here and this part here, and they are corresponding parts of those two triangles. So they are congruent. There were two different versions of the test. One of them had a rhombus for you to do quadrilateral problems with. If PS is equal to the square root of 6, so here's PS, and it is the square root of 6, what is the perimeter of PQRS? Perimeter is the distance around the outside of the shape. What do we know? Well, we know that by definition, a rhombus has all sides congruent. Now, that's not the definition of rhombus. The definition of rhombus would be a little more thorough and exact, saying that a rhombus is a quadrilateral with 4 congruent sides. But this is the key element here. If all those sides are congruent, then the perimeter of PQRS is going to equal to 4 times the square root of 6. For those of you who need to brush up a bit on the arithmetic that you do with radical statements, This is not the same as this. Okay. So that's important to know. This is pretty much as simple as you can get it. So it's just that. There are 4 of these, so it's 4 times that. Now PQ and QR. PQ and QR, again, those are 2 sides of the same rhombus. Rhombus has congruent sides. We've been given 2 algebraic expressions to represent them, 3x plus 7 and negative x plus 17. So we got to solve for x. We know they're equal because all the sides are congruent. So add x to both sides. Subtract 7 from both sides and divide both sides by 4. And your answer is 2.5. Here, if PSM is 22 degrees, where is that? PSM, that's this angle right here. Find RSM. RSM. Well, here's the thing that we know about rhombuses. The diagonals of a rhombus bisect their angles. So that means this diagonal here is going to bisect this angle. That means cutting it into 2 equal pieces. So these 2 angles have to be congruent. That means the measure of angle RSM is equal to 22 degrees. Now SPQ, where is that? That's here. SPQ, we know that consecutive angles of a rhombus are supplementary, and that means these 2 angles right here have to add up to 180 degrees. This is 22, and this is 22, which means this whole thing here is 44. So the angle we're looking for, the measure of angle SPQ plus 44 degrees has to equal 180 degrees. And that means the measure of angle SPQ is equal to 136 degrees. And then finally, PMQ, that's PMQ. That's right here, where the diagonals intersect. They say that that angle is equal to 4x minus 5. We also know the diagonals of a rhombus are perpendicular. And that means that in this particular case, 4x minus 5 has to equal 90, which means 4x is equal to 95, which means x is equal to 95 over 4, which is 23.75 degrees. The other version of the test had these questions about this parallelogram. And it first said find the perimeter. We know that this is 12. We know that this is 10. It doesn't tell us what's here or here, but we know that parallelograms have congruent opposite sides. So then that means that these 2 are congruent, so this is 10. These 2 are congruent, so this is 12. And that means that the perimeter of A, B, C, D is equal to 12 plus 10 plus 12 plus 10, and that's 44. If CT is 9, that would be here. If that's 9, what is AT? Well, that's the other thing we know about a parallelogram. The diagonals of a parallelogram bisect each other. That means that this right here, when it crosses through T, creates two congruent segments, so that means AT is equal to 9 also. Now if CDA, where is that? That's here. CDA, right here, this angle, is 60 degrees. Find CBA. CBA, this angle over here. What we know about parallelograms is that the opposite angles of a parallelogram are congruent. So if this angle is 60, the opposite angle must also be 60. The measure of angle CBA is 60 degrees. And we also know that consecutive angles of a parallelogram are supplementary. So if this one is 60, this one has to be 120 in order to add up to 180. Which one are we looking for? BAD. That's the one, BAD right there. So that has to be 120 degrees. And then finally, if AT is equal to this and CT is equal to this, now we've already said AT and CT have to be congruent because the diagonals of a parallelogram bisect each other. And that means that AT and CT have to be congruent, which means their lengths, which in this case would be 4x minus 7 and minus x plus 13, have to be equal to each other. So we're going to add x to both sides. We're going to add 7 to both sides. We're going to divide both sides by 5, and x is equal to 4.